The first roundabout in Carmel was built on River Road and 131st Street in the late 90s, around 1997. The next two were on Hazel Dell Parkway. We made the decision to build roundabouts because they're safer, less expensive, and aesthetically more pleasing. They're safer for vehicles because all the vehicles have to slow down. When comparing a roundabout to a stoplight, many times cars will speed up to go through the yellow light or speed up even to go through the green lights, and then if there's an accident, it tends to be a very serious accident, possibly a fatality. At the roundabout, everyone is going slower. And so when there are accidents, they tend to be very minor side swipes or rear end accidents that do not send people to the hospital. The other reason that the accidents are less severe at roundabouts is that one's angled as you go into the roundabout so that there's not a T-bone type of crash if someone makes a mistake. It's usually a minor side swipe that results in no injuries and relatively minor property damage accidents. Roundabouts are not only safer for vehicles, studies show they're also safer for pedestrians. At a stoplight, if there's a pedestrian vehicular accident, speeds tend to be very fast. At the roundabout, everyone's going slowly, so if there is a pedestrian accident, it tends to be less serious than it would be at a stoplight because of the lower speeds. You can also see when we design and build the roundabouts, there's an island in the middle of the street before you enter the roundabout, the island that actually makes the cars go into the roundabout at an angle. And so a pedestrian can walk out in that island area and wait and only have to cross half the street at one time and then wait until traffic clears to cross the other half of the street. Roundabouts are also less expensive to build as well as maintain over stoplights. The concrete and asphalt used at a roundabout is about the same as a signalized intersection with the turn lanes and so on. The difference, though, comes with the mechanical equipment, the signal itself. A full-fledged traffic signal with pedestrian crosswalk signs cost about $125,000, and we don't have any of that cost at a roundabout. Furthermore, the annual cost of providing electricity for the stoplight costs between $8,000 and $10,000 a year per light. We don't have any of that cost at a roundabout either, and when there is a storm and the electricity goes out, we don't have to send a police officer out to direct traffic at the roundabout because it continues to work, unlike a stoplight. You can do an awful lot of landscaping in the middle of the roundabouts for the amount saved over a stoplight. Of course, the theory at roundabouts is that no one should have to stop, or if they do have to stop, not for very long, where half the cars at a stoplight stop for half a minute to a minute, depending on the type of road the light has been installed on. So one of the advantages of a roundabout is a lot less gasoline is consumed by the public. We've estimated that roundabouts in Carmel are saving millions of dollars per year for people who just drive through them in gasoline that's not used while they sit there idling. And of course, this is correlated as well to an improvement in the air quality. Not as much gasoline burn while idling at a stoplight means better air quality in our community. We were one of the first communities in the Midwest to build roundabouts. Michigan had built a few, Colorado had built quite a few, Montgomery County, Maryland, outside of Washington, D.C. had quite a few modern roundabouts. But we were one of the first communities to really take them on in the Midwest and make the determination that they worked better than stoplights in many, many cases. A lot of people have confused what we call modern roundabouts with the old rotaries from New England. Rotaries are different. They're much more like the Indianapolis Circle. They're larger, which means that vehicles can get speeds up while they're in the circle. That actually raises the accident rate based on engineering studies. We find that the smaller the roundabouts are, the fewer accidents there are. Almost counterintuitive, but that's what the statistics and our experience show. There is a learning curve when people who've never driven on roundabouts before start to drive on them. And one of the things we've learned with experience is that the center of the roundabout should actually be built up so that the view of the entire roundabout is blocked. Again, this may seem counterintuitive, but sometimes we find a cautious driver will stop and wait until the entire roundabout is clear of traffic. when really what they should be doing is just looking to their left to look for a gap in the traffic. So by building the inside of the roundabout up with beautiful landscaping and having a bit of a mound there, actually we found makes the roundabouts operate better.
Over the years with my involvement in design and construction of roundabouts, I've learned how important it is to slow traffic as they approach a roundabout. Really the entering lane is the primary point of conflict. You have two occasions of conflict, once at the pedestrian crosswalk and once as you hit the circulating lane. So simply looking left at the roundabout at a slower speed obviously is much more manageable for a driver. As they come into the circulating lane, you just have one point of conflict looking to the left. The deflection of a vehicle is achieved by offsetting the center point of the roundabout from the traditional intersection location. So we shift the roundabout off center, and that creates a deflection or a curve in the approach lane, which causes a driver to reduce his speed to safely negotiate the curve, which also allows them to safely enter the circulating lanes with fewer conflicts. Roundabouts were used in Clay Terrace because of the mix of pedestrian and vehicular uses. Roundabouts have an effect of slowing traffic, and they were used in this particular roadway, Clay Terrace Boulevard, to help calm traffic. They also allow for the safe entry of the cross traffic from the parking areas behind the stores, but it has a primary function of slowing traffic, so they accomplish that very well, I think, in this scenario. A single lane roundabout is quite simple in its navigation. Approaching the lane, or approaching the circulating lane rather, you have one direction to look, simply looking to the left, yield to any circulating traffic, and then enter the circulating lane, find the correct exit point, and exit in the exiting lane. The key to navigating a two-lane roundabout is to pay attention as you approach the roundabout to the lane markings and the signage on the approach. There are indications as you approach the roundabout as to which lane you should be in as you enter the circulating lanes. Once in the lane, in the circulating lanes, you'll stay in the lane you're navigating until you get to your exit point, and then you would exit to the right. In some cases there are two exiting lanes, so both circulating lanes would be exiting, and those are just based on which roundabout you're in and where that location is and how many approach lanes are on each one of the approaches. But the key is, as you enter the circulating lanes, you make your selection on the correct lane before you're ever in the roundabout. Each roundabout is unique in its design. In general, though, the navigation of a roundabout is very similar to the navigation of a traffic signal. If you were approaching a roundabout and wished to turn right, you would want to be in the right-hand lane. If you wish to turn left, it would make sense to be in the left-hand lane. That's the same with a roundabout. While each roundabout is unique, there are a few where the right-hand lane will actually allow you to turn left depending on traffic volumes, or straight. It's key to pay attention to the lane markings at each roundabout to figure out its unique characteristics. But in general, we're using right-hand for right-hand turns, left-hand lane for left-hand turns.
The design of roundabouts has actually evolved since we started in 1996 or 1997 with more standards coming about. One of the major components that we've modified is adding the deflection before they enter the roundabout. Another element that we've added here recently is where there's a large right turn movement on one of the legs, we've added a right turn bypass lane, which allows those right turning vehicles to go bypass the roundabout altogether, overall improving the capacity of the roundabout. By having a constant flow of traffic, you move a lot more vehicles through an intersection on any given time frame. So there's not the normal stop as it would be for a four-way stop or a signalized intersection. Also, the safety component of roundabouts, the benefits are unbelievable. Typically, the number of injury accidents are much lower in a roundabout than they are in a standard four-way stop or signalized intersection. One of the issues that we've noticed is primarily on two-lane roundabouts is the implementation of the proper pavement markings as you enter into the roundabout. Lots of times, depending on the configuration of the roadways, you have to look at how those roads are coming in and to identify how best to mark it, kind of going away from what you just do at a standard single-lane roundabout. So it's an evolving process, and many times you even have to come back after you implement your two-lane roundabout and make some minor modifications to the pavement markings as traffic is handling the pavement markings.
Roundabouts are safer than a stop sign due to the fact that when the accidents that we do have in the intersections, they seem to be of less serious nature, more of a side swipe than a T-bone. And it's the same for a traffic signal, red light as well as a stop sign. Anywhere where there's a 90-degree intersection, when you come in at an angle, it seems to be, it appears as though we have a lot less accidents involving serious injuries. And that's why the insurance agencies prefer roundabouts in a city than the T intersections. Well, the way to drive a roundabout in Carmel, I know each person needs to check with their own jurisdiction as to how their roundabouts work, but here in Carmel, the people entering the intersection, they need to yield to anyone that's already in the roundabout. So mainly from the left. If a vehicle's coming from the left, you need to yield to those people that are already on the roundabout. When you approach the intersection, you'll need to look at the markings on the road. Most of the time, the markings on the road will assist you to tell you when you want to exit the roundabout, the best lane to be in. Some of the intersections are marked prior to, and they'll even give a little diagram on the road that says, you know, if you're in the left lane, that means you're wanting to continue through the roundabout. The right lane, you may be going off to the right. Some of the other intersections that are dual lane intersections, when you enter, if you're entering on the left lane, you'll need to stay in the left lane as you go around the intersection and exit back in the left lane. Same thing with the right lane. When you're in the right lane, you'll need to stay in that lane.
One of the reasons we like roundabouts and are using them so much in Carmel, in addition to safety, in addition to the cost savings, are the aesthetics. I think we all want to live in a place that reminds us of our rural heritage in this area, a place that's green. We don't want to see everything paved over. And so the roundabouts are a much less urban way to handle a lot of traffic in an intersection. It reminds us of a rural area. Stoplights aren't shining in people's bedroom windows at night. It's just a much nicer, more aesthetic way to handle lots of traffic. We really think too that making our streets beautiful, using a lot of our discretionary transportation money to make our streets beautiful, to make the roundabouts beautiful, is one of the best things we can do to help property values in the city as well. Look back at Irvington and Indianapolis. One of the reasons that Irvington is still doing well is because 130 some years ago, the developers of that area in Indianapolis made certain that they put beautiful medians and put fountains and made the streets in that area beautiful. And that's what we're trying to do in Carmel. We're always trying to look ahead. What can we do now that makes this a beautiful community, not just this year, but 25, 50, and 100 years from now?